You may have seen the will it start genre on YouTube for old cars. Well, this is the steam engine version of that particular clickbait. So will it start? Hello Internet, my name is Quinn and this is Blondihacks. I'm back on the big steam engine this week and I'm going to make all of the lower valve gear. So that's the eccentric strap and all the little bits that connect it all together. The important thing about this though is that once this is done, this engine will be able to run on air for the first time ever. You're going to see everything run at the end of this video. So it's going to be incredible. Stay tuned. Let's go. First up is the eccentric strap. This is kind of the brains of the engine. The kit supplies this rather complex casting here. It needs a fair amount of cleanup. I will say this is probably the roughest casting that I've seen in this kit so far, but that's okay. We can work with it. So as usual, I do most of the work with the Dremel, and then there's a very large chunky sprue here that was going to take all day with the Dremel, so I took a file to that. And that is looking pretty decent there. I think we're ready for some machining. Strap and clamp features like this on steam engines are all made basically the same way. You drill and tap the clamping bolts on the sides first, and then split the clamp, and then machine everything else. This particular one, it has that big chunky boss at the end of it, which makes clamping it difficult, so I decided to clamp it upside down like this. So I started by setting up the bosses there, centering them up with a gauge pin roughly the size of the boss, which is a tip that I got from my viewers. I was just about to set up the tooling to start milling and drilling this, and I realized, oh, I can't do it this way because the bolt heads would be on the wrong side. So I need to flip it over, and I clamped it up instead with this sandwich of parallels for spacing blocks and emery paper once again. Then once again located the bolt holes with a gauge pin on both sides, and also making sure that the spacing is correct according to the DRO. And then to make sure I've got the piece sufficiently vertical, I check in front of it here with a drill visually. That is the clearance drill that will be used in the top half of the strap. I'm just making sure that's not going to break through anywhere weird. That looks good. I will start by spot facing the top here so we get a nice purchase for the drills. And there's a little bit of interference there with the casting curvature there that we need to clear out. I'm going back and forth between the holes to minimize tool changes. I have the positions of each of these two bosses set in the DRO. So each side gets center drilled after the spot face, and then the tapping drill size goes all the way through the entire casting, coming out the bottom of each of these two bosses. And then the top half of each hole is clearance drilled for the bolts, and that's what forms the strap. It's kind of like a clamp, but you don't want it to actually clamp on the hub in the middle of this. It's just being held in place. To set the depth for the clearance drill, I just touch up on the drill and zero the quill DRO there, and then I use that to drill down half the depth of the casting there. You want to be reasonably accurate with this, but as you'll see in a moment, you can compensate if you miss a little bit on the halfway point here. Then we tap the bottom half of this hole. Hopefully it's the bottom half at least. It's whatever's left of the tapping drill size at the bottom of the clearance hole there. Once again, this is all standard procedure for this type of part on a steam engine. Quick test fit with the bolts that came with the kit. I'll be replacing those with studs and nuts, I think, but for now I'll use them, and that looks good. There's a moment of truth here when we take the part out, flip it over, and see how those holes came out on the other side, and hopefully they're reasonably centered, and yeah, those look pretty good, so I think we'll roll with that. And now we take those bolts out, of course, and split the casting in half. Once again, get this as close to in half as you can, but you know, it's a casting, it's never going to be perfect, just do the best you can. The goal is for the slitting saw to split those holes right at the transition from thread to clearance hole. But as I said, if you don't get this perfect, we have a chance to compensate here in a moment. Clearances were close on my arbor and my spindle there, but luckily I did manage to get this done in one pass, which is always nice with slitting saws. With the casting split, we can now bolt it back together, make sure the castings are aligned as best we can, and then measure it one way and the other to see how out of round it is. The casting is intentionally out of round here so that we have room to machine them flat at the interface here. Those measurements tell us how much we need to remove to get the center hole round, and we can remove that equally from both sides, or if your slitting saw didn't land in the right place, you can mill a little more off one side or the other to expose the threads or the clearance holes as needed. I'll take this opportunity to point out that somewhere in the middle of this process, I looked at the drawing again and realized that no, actually, the bolt heads were supposed to be on the bottom of this part because then they're facing up when the part is installed. so I had this set up right the first time. Sometimes 2 rights make a wrong. But I was committed at this point, and it doesn't really matter which side of the part those bolts are on, so here we are. Then bolt it back together, and if you did your job right, then the casting is now nice and round. At least mostly round. We're going to be machining this anyway, but the rounder you get that casting now, the better. The next step with a part like this is always going to be some kind of fixture. I've never come up with a magic bullet fixture for eccentric straps that I like, so I keep experimenting. In this case, I grabbed a piece of Mix 6 gauge plate, which happens to be aluminum plate intended for fixture making. I happen to have some that was donated to the channel. I cut a piece of that, cleaned up the edges, and I thought, well, if I lay the eccentric strap on here like this, I can clamp it down. Then I realized that boss sticks up and it won't sit flat, so I thought, well, I'll just stick the boss off the end there and that'll solve that problem. Right? Right? I drilled and tapped a couple of mounting holes for some clamps. This is all going to be to set this thing up in the lathe, of course. Next, I grabbed a little piece of scrap and I milled an L shape into it. This is going to be kind of like a miniature toe clamp, if you will, for the top half of the eccentric strap. This gets a little clearance hole drilled into it, and now you can see how this is all intended to work. The bottom half there, I just grabbed a piece of brass square bar with a clearance hole to clamp that down, and then the little toe clamp there clamps on the top of the clamp like so. This seems like it's going to work. But of course I made the classic mistake that I always make with these parts, which is I designed the fixture before doing all that clamping bolt work on the part, and well, now the part is shorter and my clamps don't work. So I went ahead and made a longer version of that little toe clamp, and now I can clamp it up as intended. If only that was the end of the trouble on this part. The idea here with a fixture plate like this is that I can clamp the plate up in the lathe and I can get it running true and flat, and then I can clamp the part to it and be able to trust that the machined part will come out nice. I start by getting it flat in the lathe here. It's not running very true. I don't know if there's a warp in this plate or if there's some damage to the backside, but I couldn't get it tapped in flat, so I put a little shim down the low corner there, and I got it within a couple of thousandths, so I think that'll be sufficient for this. Next, I can install my clamps and get the part set up in here. And this is where I realized the flaw in my plan to hang that boss off the end of the fixture plate. I did briefly consider clamping the jaw on the boss and only clamping the plate with the other 3, but this just didn't seem like a good idea. Instead, I went back to the drawing board on this plate and I made a new one, which is the same except that it's longer and has a slot in it to accommodate that boss. And now the casting can sit flat on there and the jaw has somewhere to clamp. So we're in better shape already. I wish we were out of the woods yet, but we are not on this part. Eccentric straps are never easy. Off the bat, that's of course running out, but it's actually not bad considering everything was clamped up arbitrarily. But now I get the dial indicator in there and start lining it up. 90% of this part gets machined, so we're not necessarily trying to align with any cast details per se. As long as I get the casting that's in there reasonably concentric, then the end result is going to be fine. This casting, as I said though, is pretty rough. I only managed to get it to within about 10,000ths of running true, but the old Mark I eyeball seems to say that's running pretty good. So let's go ahead and start machining this. In comes the boring bar, and we need to bore out the center of this thing. There's a target dimension that we're aiming for on the drawing, but of course if we miss it, it's not a big deal because I'm going to make the eccentric hub second, which is by design because it's much easier to fit an outer diameter part to an inner diameter than the other way around. A bunch of boring and sneaking up later, and hopefully we're on dimension now. Final check with the telescoping bore gauge, and survey says we are right there. That's on dimension. Maybe a couple tenths under. I'll take it. Now, however, is revealed the genuine fatal flaw in this fixture, which I'm sure many of you saw coming. I do actually need to face the front and back of this strap, and my little toe clamp there is preventing me from doing so. That was not well thought out. As kind of a Hail Mary, I thought, well, I'll try boring away most of that clamp and see if I can get enough of the casting exposed that I can clean up that surface. Predictably enough, that failed because the clamp moved under the force of that boring bar. It only had a single small bolt holding it. And now the part has moved, so concentricity is lost, and, well, cats and dogs, it's all chaos. So plan B, over to the fixture plate on the mill, and I turned up this little button here that is a very close fit on the clamp and was faced in the same setup, so the bottom of it is extremely square. And that is going to hold the clamp square to this fixture plate, which is going to allow me to machine the faces of it, and they'll end up very square to the bore, which is the ultimate goal with a clamp like this. Here on the mill, the clamps are still in the way, but I can put multiple clamps on there, and I can play musical clamps as I go here. I can mill around them and then move them and then machine the areas that I couldn't reach and so on. This is something that you can't really do on the lathe. You have to be able to machine it all at once. After having done a few of these, and maybe you already had this idea, the best way to clamp a part like this is probably to use those bosses themselves. Make some little L brackets or something that would allow you to clamp the part to those threads that are there rather than trying to use any of the outer surfaces. I think that will probably work. The trick though is you got to be careful how you do that, because you can't unbolt the part ever once you've started machining it. The whole process here depends on keeping those bolts in place for the entire time you're machining it. So if you're going to design a fixture that uses those bolt holes, make sure it doesn't require you to ever separate the part, or you're going to lose the alignment that you're carefully earning here by machining everything with it bolted up. Onto the boss at the end there, you can see it's actually a through hole, not a threaded hole like one might expect. It looks like there's a jam nut there, but in fact there's a sneaky extra nut off to the side there that indicates that this is actually a through hole that's nutted on both sides. I almost missed that the first time I looked at this diagram and thought, that must be wrong, I'm going to thread that hole, and luckily I caught it at the end here. If this was threaded, I think it would actually make assembly of the final engine impossible, and that's why they do it that way. This is a pretty easy thing to do now though, because the part's easy to clamp in the vise. I machined the top of it nice and flat there, no dimensions here. Then I used a piece of scrap that was the same diameter as that boss to center it up, and then I center drilled and drilled this through, first with a very small drill that goes all the way through both areas because it's also the oil hole for the eccentric there. The reason that I centered up on the boss and not with an edge finder on the strap itself is because the location of this hole on the boss is actually just aesthetic. We're going to be bending the valve rod to wherever this hole lands, so it's more important that it looks good on the top of the strap than it be perfectly mechanically aligned with the bore and so on. On to the mating part now, the eccentric hub. These are always really cool, iconic parts on a steam engine. I always like making them. I'm going to start by facing off the front here, as is tradition. This piece of stock here came with the kit, and it's worth noting that they barely give you enough for this and also the piston that came out of the other end of it there. I barely have enough to hang on to it with the chuck, which is going to affect some decisions here in a minute. But I start by cleaning up the OD. Once again, the stock is right at nominal dimension for the part, so I'm trying to skim as little as I can off of there to clean it up. This kit does a lot of that, and I'm not a big fan. I wish they would give you oversized stock for everything. The critical feature of this part is, of course, the groove that rides in the eccentric strap. This is where I'm going to start spending some time. I'm going to start by translating over for the thickness of the shoulder of one side of the eccentric hub there, and then I start feeding in to create the groove. I feed in very slowly until the cutter just touches off, then I zero my cross-slide hand wheel there, get some lubricant in there, and start feeding. Now this is a fairly aggressive grooving operation for this little lathe. The diameter is fairly large and that grooving tool is fairly wide, so you can see I had some chatter issues at first, so I had to slow the lathe way down. This is, I think, about 50 RPM. That was enough to eliminate chatter, but the lathe does not like holding RPM this low, so it is struggling a little bit here, as you can see. But I did get away with this. If this had not worked, I would have needed to go to a narrower grooving tool, perhaps a parting blade, something like that. With a feature like this, where I'm aiming for two critical dimensions simultaneously, in this case the depth and width of this groove, I try to focus on one at a time if I can. I find that works pretty well for me. So I'm stopping short of final depth here, and I'm going to establish the width of this groove first. I have a dial indicator set on my carriage out of frame there, so I know exactly where I started the groove on the one end, and then I'm working my way down to the other end, always stopping short of final depth, and I'm using an adjustable parallel as I go here to keep an eye on the width, and this allows me to just worry about getting the width exactly perfect first, and then with the dial indicator on the carriage, I will know where the two sides of this groove are so that I can then focus on the other dimension without messing up this dimension. With that established, now I can bring in the micrometer and start worrying about the depth of the groove here. I'm close there as I expect it to be, so now I can just feed into final depth and then do a light sweeping cut across, feeding laterally with the grooving tool, which you can do as long as it's a light cut. And that leaves a nice finish and should leave me right on dimension. Yeah, survey says we're about 8/10 under where the strap landed there, so I'm very happy with that. Next is the very critical fitting up stage here of the strap, and I will share a few tips that I've learned the hard way. It's not likely to fit the first time, but the reasons for this can be unintuitive. First and foremost, in my case, the width was actually a little too tight. So I went ahead and widened that out a little bit here, but the key thing with fitting up these straps is don't just start making cuts. Take a lot of measurements and figure out where the problem is before you make any cuts, because again, the answer is often unintuitive. In my case, I definitely had to widen the groove a little bit. The next thing I always recommend is chamfer those edges where the straps meet there, because if your split line on the strap is not perfectly on the center of the circle, you're going to have a little bit more than 180 degrees of arc above or below the split line, and that's going to keep the strap from sliding perfectly over the eccentric hub. The other thing I recommend is taking a thin parting blade and just undercutting the insides of those shoulders a little bit. Only has to be a few thousandths, because that's again a common area where you get interference. The cutting tool leaves a little bit of a fillet in there, and you can chamfer the strap as well. That helps as well, but the point is to try all of these things first before reducing the diameter of the center of the hub. That's going to be your instinct. That's going to be the thing that you think you need to do, but you're probably wrong, and then you've ruined the part. My final tip is once you're really close like this, like it feels like it might go on or it does go on, but it feels tight, then start test fitting with the bolts installed and torqued down. Because once again, if you've got just a little bit of off center on your split line there, even like too small for you to see, then the fit might seem like it's tight, but when you torque down those bolts, the two halves pull together over the hump as it were, and now the part spins freely. That's what I've got here. I tighten the bolts down a little bit, and the strap is spinning fairly well, and I tighten the bolts up further, and now the strap spins very freely. And all this is why turning down the center of the groove should be your absolute last resort. Measure everything multiple times to make sure that that's not your problem, and then trust your measurements and look for other sources of interference between these two parts. With that part fitted very nicely, now I can part it off. I still have the off-center hole to drill here, and normally I like to do that kind of feature in the lathe because eccentric turning is always fun, but it does involve offsetting the four-jaw chuck by quite a bit, and that's not something I like to do unless I have really good purchase on the stock, and here I do not. I've only got a single tooth on the stock there because of how short it is. So I decided to instead part it off now, a little bit oversized. Then I can flip it around, and I'm going to put it back in the four-jaw with some packing blocks here, and I'll face down that other side so that the shoulder there ends up the same width on both sides of the part. I used a stack of parallels there behind the jaws to tap the face in parallel to the chuck face there. I'd like this part to be, reasonably parallel front to back. It's mainly aesthetic, but I'd like to get that good. I did not, however, bother dialing it in axially as you see here because we're just facing, and that's just not worth the effort. There we go. Now over to the mill, since I can't do it the fun way on the lathe. I've got a little mini V-block here that's just a scrap that I had that happens to have a V cut in it. It's handy for little setups like this. It'll give me a little better grip there on the part, and I'll use my coaxial indicator to get it centered up. I wanted 3 points of contact here since we're going to be drilling. There's going to be some twisting forces on this part. I don't want it to rotate in the vise there. Then using the DRO, I offset to where the drawing says this is supposed to be, and I drilled it out in a series of larger and larger drills. When I get up to the larger sizes though, luckily I have these reduced shank drills which will go in a collet because I've run out of room vertically for my chuck. And that allowed me to get up to the pilot drill size for the reamer for this. This is the 5/8 reamer that I bought special for this project. I've been using it in multiple operations. What's great about it is that it happens to have a shank that will fit in a collet that I have. A lot of chucking reamers just have really random shank sizes on them, which is problematic. Even still though, you can see I don't have room to get the reamer in there, but luckily with the DRO it's easy to move the part out of the way, which buys me just enough space to get it in there and then move back to where I was, and I'm not going to lose any accuracy here. That reamer did a really beautiful job in there. That's looking good. Now we need a little set screw there to hold this in position on the crankshaft. This doesn't have to be super accurate. I did use the edge finder to center it up on Y, and then for X position I just eyeballed it with the drill there. Make sure it's coming out basically at the center of the top of the hole there. We do need to deburr the inside of that hole there where it interferes with the bore. So for that I'll take any excuse I can to show off my little inside bore deburring tools here that I love. Hashtag not sponsored, but there is a link to these below if you're interested. I love these little guys. If you don't have something this fancy, you can also just run the reamer through that hole again by hand, and that'll usually remove any burr in there. But you know, if you got the fancy tools. Okay, we're getting really close here. It's getting exciting. I'll install the eccentric on the crankshaft there, and I'm just going to eyeball the valve timing. I'm going to set the eccentric 90 degrees off the crankshaft. This is usually close enough to where the engine will run. Which direction it's going to run depends on whether you go plus 90 or minus 90 here, but we'll fine tune this once the engine is running. I'll get some startup oil on there and install the eccentric strap. You can see once again that it seems like a tight fit until the bolts are torqued down, and then magically it loosens up and it runs perfectly. The valve rod needs a hinge in it, so I'm going to knock that out here real quick. I'm not going to show this in a ton of detail. If you're interested in this part, I made the exact same one, only smaller in my previous engine build, so go ahead and check out my playlists for the PM1 engine. But you can see basically what I'm doing here. I made the two parts on either end of the stock, used the roundover jig there to round the ends, separated them, cleaned up the ends, put some holes in them, etc., and that's the final clevis there. And those go together with a precision ground pin that came in the kit, which is nice. It'll stay in place, but it's easily removed, which you need to do in order to take the engine apart. You can see how this all goes together now. Now the lower valve rod does actually need a bend in it. As you can see, it does not align with the eccentric as expected. That's how it's supposed to be. So we got to mark a couple of bends in it, and the drawing has a bending diagram for this. I marked the locations of the bends on the rod here using the diagram, and I annealed the brass in those two places so that I can bend this without risk of cracking it. And you just basically eyeball it and take your best shot at it. You'll go back and forth a couple of times fine-tuning those bends until the valve rod comes out in the correct place. If you do it right, you can install the lower end like so with those nuts, and then the upper end should just slide right into place with no interference or stress on any of the parts. I think I went back and forth 5 or 6 times to get the fit just right like this. Now we can slide that pin in there. Now to set the valve rod length, I pull the valve to the bottom of its travel, and the upper steam port should be just exposed there like that. So the top of the valve is sitting at the bottom of the port, fully exposing it. And then at the top of the travel, the port should be fully covered. And that's close enough to where hopefully the engine will run, and then we can fine tune from here. So I'll get the valve head back on there. Just cranking the engine over by hand now. You can see it is moving air. The tissue is flapping there. That's a good sign. There's no gaskets and no piston rings in it yet, so the fact that it's moving air already is pretty darn good. And well, if it's moving air, there's a good chance it's an engine, so let's put some air in and see what happens. This is genuinely my first attempt to put air into this engine. You are watching it for the first time with me. I have never seen if this engine will run or not yet. Here goes. Oh, look at that. Look at that. I don't think I've ever had an engine just fire up and run first try like that with no 20 minutes of futzing with valve timing required. I must have gotten incredibly lucky on that eyeballed valve timing that I did, because the engine just runs almost perfectly. It's kind of shocking. The next test is to run it as slowly as I can here and listen to the valve timing. The goal is to get the valve timing to sound symmetrical, but honestly, that sounds really good. I mean, there's maybe a little tuning I can do there, but gosh, I think that might be the luckiest eccentric setting I've ever done. Let's check the pressure now. I'll see how low I can get it to run. That right there is about as low as it'll run. So that's between 2 and 8 psi. Let's call it 6. So I'm very happy with that. Again, there's no gaskets or anything in this engine, so for it to run on 6 pounds, I'm very happy with that. It mostly sounds really good. There is a slight ticking in the bottom end. I think it's coming from the connecting rod, so I'll need to spend some time figuring out what that is, but otherwise, very pleased. I'm doing a lot of editing around the compressor noise here because this thing is consuming an impressive volume of air, which I think is down to the sheer size of this engine, the tiny size of my compressor, and also the fact that, of course, there are no gaskets or rings in anything. It'll be interesting to see how much air this thing needs once it's all sealed up tight, but so far it's pretty impressive. I have no idea if I'm going to be able to build a boiler that'll run this thing, but I'm sure enjoying running it on air, and I hope you are too. With the engine 90% complete, I had to see how much does it actually weigh because it feels like such a monster. Survey says 29.6 pounds. So yeah, that's a beast by model engine standards. And once again, I guess technically this is not a model engine. It is in fact an actual 1895 farm engine that was offered for sale. But I'll leave it here for now. There's still lots more to do on this engine, so stay tuned to this playlist. Thank you for watching. Thanks to my patrons for supporting this project and all my other work, and I'll see you soon.